All right, welcome to the AdaptX podcast, where we have conversations with individuals who are building accessible products or businesses, advocating for inclusion, or excelling in adaptive sports. Our intention is never to speak on behalf of those with disabilities, but give them a platform to amplify their voice and share their insights so we can make a more accessible world. Today, we are joined by Greg Vanderbeek from the College of Engineering and Applied Science at the University of Colorado. Greg, thank you for joining me today.
Thank you for having me. I'm actually really excited to be here and have the opportunity to talk about some of the things we're doing. And I don't know, just looking at a lot of the podcasts you've had in the past, it's an honor to be on it. You got some really amazing athletes and individuals that you've spoken with. So thank you.
Yeah, it's been a pretty crazy 7 or 8 month run since starting this. I feel very fortunate. The conversations I've had, I don't know exactly what the outcome was when I started it outside of sharing the lived experiences, but now I feel like we have this huge content base that has so much like wisdom and lessons learned that we can hopefully share with a lot of people. But I was first introduced to your work a month or two ago when I read an article. We write a bi-weekly newsletter, insights into inclusion across different industries, and I was just doing a Google search and came across an article in the Gunnison Times, maybe out in Colorado. So you're using your platform, your opportunities, your resources at the University of Colorado to design an adaptive bicycle in one of your engineering programs. And that was a project that I found to be really interesting, like a university partnering with local organizations and actually having a tangible product that benefits people with disabilities. So interested in learning about how that came about to be. So if you want to take me through the process, maybe when the concept was first introduced to you and how you worked it into your curriculum or your courses.
Yeah, absolutely. Taking a step back to start, just kind of talking about the program gives a little bit of insight into why and how we were able to do this. We're a partnership program between the University of Colorado Boulder and Western Colorado. So the reason why that's been advantageous is that we have a full engineering program, but we have really small class sizes. We have a state-of-the-art facility that was just donated by an alumni, Paul Rady. And so we have this amazing facility manufacturing metals, plastics, all of this, and we have these small class sizes. And what small class sizes do is they allow you to do really fun and unique projects. So when we first started this program, it was really just 5 years ago. We graduated our first engineering class just last May. A couple of years ago, we reached out to the Adaptive Sports Center in Crested Butte, which Crested Butte's just 25 miles north of Gunnison, where Western Colorado is located. And they're a world-class facility. They run summer and winter programming camps. They work with veterans and all different types of athletes with disabilities to do snow and summer sports. I mean, rock climbing, rafting, all these things. And so we went up there and talked to them several times, just kind of saying like, look, we're a project-based group, like we're in a mechanical engineering department, and one of our key differentiators is we want our students building things right away. Like we want engineers that are industry ready, and industry ready means that they can both see the problem, work through the problem, and actually develop a product that is worth producing. And so we asked them, like, what do you guys have any needs where you wish something was out there, but it's just not? We would love to kind of collaborate with you. And one of the vice executive director there, Chris Reed, was like, you know, it would be really great. We have some awesome mountain bikes. We have some awesome road bikes, but so many of the athletes that come here, they don't want to go out on the road, and they're not quite physically ready to do some of the trails that we have here. We would love to have like a gravel specific bike. And specifically, they wanted something that was very light and not pedal assist, so that it really kind of empowered the athlete of like, look, this is an efficient pedaling bike. You can really get out there and get into some adventure. So we started down the road of how do we design this? And, you know, at first it felt really overwhelming. And I just started reaching out to groups and thinking like, who else could we partner with? And so started talking to some CU alumni and got in contact with the folks at SRAM, and SRAM said, this sounds like a great idea. We would love to support you. So SRAM started donating some kits and Grupos to us. And then one of the key differentiators is, I'm sure some people are familiar with the Athertons. They're a world famous downhill family. Like their family has won many, many World Cups, and they started a company that started printing titanium lugs and then gluing up carbon fiber into them. And what that does is it allows you to make truly custom and adaptable as far as like geometry bikes, but you don't have to have these really expensive molds. So you can do small runs. So we started looking into it, and it turns out 3D Systems, I had a friend that was working there, another CU graduate. And so I reached out to 3D Systems. And I was like, hey, I got a crazy idea. Would you be interested in supporting something like this? And then 3D Systems is one of the top additive companies out there. I mean, they serve aerospace and biomedical. They're in automotive. They're all over. Their founder created the first 3D printer. I mean, they're a institution. And so their answer was, yeah, this sounds really cool. And so that really kind of energized me of like, wow, like SRAM and 3D Systems and these other groups are really interested in it. Let's see what we can do. So we looked at our curriculum and said, how could we make this? Because we're not going to be able to do this in a semester, and most classes are started and finished in a semester. So we created a 2-course sequence where the first semester, called component design, they design the models, they do FEA analysis, that would be finite element analysis, where you put stresses and strains onto it, you see where failure points could be, and then the next class in the series is manufacturing processes. So we're in that class right now. And so they take the bike they design and then they manufacture it. And we then iterate again, and it's been a standing project. We're in year 2. The first year, we did a proof of concept, Gen 1, to make sure we could do it. And now we've added some bells and whistles to it. And we're actually designing for a specific athlete and then designing a general use bike that we hope to donate a handful to the Adaptive Sports Center in Crested Butte.
Yeah, so maybe let's talk through the process. So what comes first? The problem, the solution, the specific individual? Are you designing from the get-go with a specific person in mind, or do you have some frameworks that begin the process?
Great question. And, the typical engineering answer that is fun and frustrating is it depends. So if you have an individual, and so this year we are going 2 directions with our design. We have a high performance bike that we're designing for a high fives athlete number 104, Justin Pines, who is going to race this bike this summer in gravel specific rides. So we had him come out to our campus. He's actually a product developer and he lives in the Front Range. And so he's very familiar with this process, and he had some great conversations with students about like, you have to get, user buy-in, and really challenged the students with a lot of these concepts and a lot of these things you wouldn't think of as an able-bodied individual. You just don't think about certain things when you're designing. And that's one of the reasons why I love this project, is it really kind of shakes up some of your traditional engineering where you just see a cut and dry linear approach to a problem. It's like, no, there's a lot of specific use needs that are going to change your problem statement even as you're moving along. So we're designing 2 bikes this year. One is a high performance bike specifically for Justin, and then we have another team that actually decided on their own that they wanted to break from the first group, and rather than just design a high performance bike, they wanted to design one that was more accessible. And what I mean by that is the high performance bike, some people that are familiar with some of these adaptive bikes, the forward facing bikes don't have as much adjustability. And they're really built for a specific individual because they're not very accommodating. If you take somebody that's a couple inches taller, they wouldn't be able to fit in a bike that was made for somebody just a few inches smaller. There's not a lot of flexibility in those designs. Whereas the recumbent bikes can accommodate a lot more end users. So a larger user base, there's more flexibility in that. And so a team of students broke off from the first team and said, we want to rethink this all together and stay with the same approach of using titanium 3D printed lugs with carbon fiber, because in this design, we think light is right, because part of the accessibility issues that our user base has talked about, as one athlete looked at me and goes, have you ever tried getting one of these bikes into a car? Yeah. These things weigh 60 pounds. Like, you try to lift that up. He's like, I'm in a wheelchair. And I'm like, wow. And if you ever Google videos of how people get these bikes into their station wagons, their vans, their trucks, it's incredibly creative and inspiring. But it's also like, wow, there's got to be a solution. So we're trying to hit a 30-pound mark, which would allow somebody to kind of lift up the front end, stick it in there, go around to the rear, have wheel locks on it so that it stays in position, and then they can lift up the rear and put it in. The feedback we kept getting from athletes is, I don't want to have to ask my buddy to load my bike. And then I don't want to get to the trailhead and say, hey, is there anybody here that can help me get this thing down? So that independence. And so some of those things are never thought of in the early stages, young engineers working on these problems. So that's been a really fun approach, as these things have kind of been fleshed out. The students are like, okay, yeah, now I see why I'm doing that. Okay, that changes things.
Yeah, I like, because when you first said accessible for that second group, my thought process was socioeconomically, like how expensive it would be to replicate these bikes. Because when they're highly customizable and when they're built with these ultra lightweight carbon
Yep.
fiber materials, they're going to be more expensive, right? So I hadn't even thought about the weight requirement, but it's also probably ease of use too. Gravel bikes going up different terrains,
Mm-hmm.
different elevations. You probably want a lighter bike in that regard as well. But what's the process of making something scalable from an engineering standpoint?
Yeah, you really hit it on the head. The titanium 3D printing is amazing. It's exciting from a student standpoint. We love teaching that type of additive manufacturing. But as we design these bikes, we're in year two, so we're still not approaching it from a value engineering standpoint. We're still in the, how are we pulling this off? Functionally, how is this working? And you can really capitalize on additive manufacturing. It's, if you can draw it, it can be printed. There's obviously some limitations there, but it's pretty fantastic. So this bike that I was speaking of, that is easier for like ingress and egress, but still remaining incredibly light. The next step for this one is to do some value engineering on it. We've set a goal, and I don't know if it's obtainable, but we've set a lot of goals and we shoot for them. That's just part of what we do, is like try to manufacture and create a bike that would be this light, so right around that 30-pound mark, but under $5,000. I think if that could be done and if that could get out into the market, and so to do that, we're talking welded aluminum lugs. We're talking about slip fits with the carbon fiber and just a different process than titanium printing. So I see, as we continue to grow, we just continue to push the envelope in different arenas. I think we will always continue to try to push the performance envelope. I think some students are really excited about that, but I think we also need to push the accessibility envelope, and that is a broader stroke. That is ingress, egress, that is size, right? If you think about somebody trying, if they're in the city and they want to get this thing out, and they got to go down an elevator, like how are they taking this thing through a standard door? Some of these bikes you can't fit through a standard door without some pretty impressive like canoodling. It's like, moving a full-size couch into a small house. It's like, how do we do this? And so we've had conversations of, could we unpin like two of the non-drive wheels, so that it becomes skinnier? Is there a way to attach it to the back of a wheelchair, so that you could fit into an elevator with it? So I don't see any end to the design challenges with this. And I think that anyone who's been in human-centered design is probably shaking their head like, yeah, as soon as you bring like use cases and human needs into this, like the design landscape just continues to get bigger and bigger. And from a teaching standpoint, that just gets me more and more excited, because we're never going to say, yep, we did it. All right, what's the next project? I think this can continue to evolve for years to come.
It's related but different topic, but I think it might have been back in at the Chicago Marathon. The push rim wheelchair racing technology is really taking off, and there was a little bit of criticism in terms of like the fastest in the world have sponsorships and access to these push rim wheelchairs that cost tens of thousands of dollars,
Yeah.
and the amateurs getting into the sport have no possibility of competing with them because this technology has such a large discrepancy between the accessible price point and the elite price point. So it's just making even a wider gap between the top tier and the lower tier, and a technology issue that's not really seen in able-bodied sports. So it's a interesting discussion on like at what point is technological advancement too making too big of a difference or too big of a discrepancy, at least in the competition space. Maybe not in the just recreational adaptive sport space, but something that came
Yeah,
to mind.
absolutely. And I think some of the component groups, so, early on with my discussions with SRAM, but, they've been incredibly supportive, and they're, seeing this as, almost through a new lens of like, wait a minute, how are these companies using our products? Because if you look at it, they're flipping derailleurs. They're taking parts that are meant for two-wheel bikes and they're making them work on their three-wheel bikes. And so I wouldn't be surprised if there's some discussions, hopefully, that shake out from some of these partnerships where SRAM, a global, the global leader in bike parts, doesn't say something like, why don't we help a little bit? Like, they're a very inclusive company. They're somebody that is interested in getting more individuals out on bikes. And so hopefully part of having these conversations and doing projects like this is to get people thinking like, yeah, maybe we can do a little bit more. And so I hope that one of the things that comes out from this is that more companies are starting to get interested in maybe dabbling and helping, because that would bring some of the cost down.
Yeah, not only companies, but individuals as well. I guess there was this quote from Chris Reed, the program director at ASC in Crested Butte, that really resonated
Yeah.
with me when he was kind of talking about designing the adaptive cycle. And he talked about how it has a ripple effect and supports a much bigger idea that the students will begin their engineering and design careers with accessibility, access, and equality at the forefront of their minds. And that's the same way that, like, when I guest lecture at a university, or when a university student takes the course that we teach on inclusive fitness, it's like maybe they're not going to be able to implement it at the university setting, but I feel confident knowing that they're going to go out into their careers with like a different mindset and approach to inclusion. So I was wondering if like you've noticed a noticeable shift in your students' way of thinking about accessibility or inclusion.
To a degree, I think there's been a full shift in just how they approach design altogether because of how broad this problem statement is. And I've kind of said from the beginning, I would be surprised if we truly create something that is, say, revolutionary in this market. My bigger interest is training a new generation of engineers that are interested in pursuing the products like these, and they're the ones that are going to go out and make a huge difference in this market. And I've had students come up to me and say, "So, what kind of jobs are in this area?" And I'm interested in this. And one of our students went and interned at the Adaptive Sports Center in Crested Butte over the summer, and I had a conversation actually this morning with one of our awesome students, G. She was like, I would be really interested in prosthetics. Like, how do I pursue that? So having some of those conversations now is exciting for me because it's like, great. Like, not that I don't want students talking about going into, automotive or some of these or manufacturing. Like, I'm not worried about dipping from that pool at all. I'm excited to hear that some of these students are like, hey, this is a cool project. How do I do that? How do I do this at a bigger scale? Like, what companies are out there? And I think the adaptive market in general, it's getting better, but I do still think it's an underserved market as far as available products. And I understand the reasons why, the challenges of designing in this area, and market share and all that kind of stuff. But I do think a change is happening right now where we're seeing just better products out there. We're seeing more technology. We're seeing a lot of really great engineers that maybe would have gone into a different field, but they got excited to get into this field. And so that's an area that I think that a university can make a difference by creating projects like this, that you get a couple of really excited students. They can make a really big difference in their careers.
Yeah, we talk about how universal design and accessible design benefits all populations. So maybe there ends up being a trend towards just products being designed for all individuals, regardless of ability or not. Kind of on that topic, how that you just mentioned, how can universities more effectively collaborate with organizations?
I think it just starts with reaching out. I think sometimes this is normal, but I think sometimes we get stuck in our ways of just like, ah, this is how I teach this class, and it's harder to be creative and to come up with unique ideas. But so far, in my short experience with reaching out to adaptive groups, adaptive companies, they've welcomed the collaboration with open arms. One of our professors, Mel, she reached out and had a contact within Limitless. They do, and our students designed a new button for them. And our two patents were, I think, are being shaken out from that. And those students, that made such a huge difference for them. And it all started with a phone call of just like, hey, I got an idea. I think you had a cool product. Would you have any interest? And that's where I think a university, that's where I think our strength is. Like we can offer things like we're a nonprofit. We don't have to adhere to any of the traditional things that businesses would have to do. Like our outcomes are just exciting students, hitting learning objectives, making sure that we're meeting our goals for what the students need to learn. And so we have a really big freedom to reach out, be creative, and if a project doesn't do amazing, oh well, right? You're still, that doesn't mean you didn't learn from it. That doesn't mean the students didn't get a lot out of it. Sometimes you get more out of failure than you do from success. So I think it just starts with just reaching out, and I think it can be twofold. Like I think companies could reach out to universities and say, hey, we would be interested in doing a project, because oftentimes it doesn't take much from the financial end. It's more of just the collaboration. An individual from that company kind of championing the cause, sitting down, talking with students, meeting with them regularly, and spending that time. And that interface, I think, has so much value in it for students to be talking to professionals, individuals that are truly trying to launch products, and or they're part of an organization and they're trying to serve a need within their organization. I think tackling those real problems are traditionally better learning outcomes than just say some book problems.
Yeah, mutually beneficial for both, and it's a university is a safe setting to learn and fail in, as opposed to
Oh
out in your
yeah,
career. It's a good place to develop or to determine what works and what doesn't. Uh,
absolutely.
Maybe looking at the future of 3D printing and accessibility, do you see what direction it might kind of benefit assistive tech, prosthesis, etc.?
Yeah. So 3D printing has already made a huge impact, right? The metal 3D printing is pretty phenomenal because that's a final product. Like for example, the titanium that we're printing on, we've been doing a lot of generative design where you remove mass from areas that have no stress and you add mass to areas that have stress. So you model it to essentially make the strongest, lightest component. And we have these lugs that feel so light, and yet just the other day we were putting it in a test apparatus and we couldn't even break it at 1,300 pounds of force, and we only needed 500 for our safety factor. So from a metal standpoint, things are ready to go. But from a plastic standpoint, a lot of the plastics are getting better. But the other area that they're really making a difference is you can rapidly make molds. And so the 3D printing might not be what you actually have in your final product, but it could create the mold, for example, for like a vacuum thermal formed Kydex, like a type of plastic. So you could scan, say like an individual's leg. Let's say you're making a prosthetic. You could scan that individual's leg and then bring it over into the model, reverse it and print, and then that's your mold. And then you could use what would be a long-term plastic, like a thermal set or a thermal form plastic, and then wrap that around it. So the 3D printing has really helped from a rapid prototyping standpoint, to see if something fits, if it would work. And traditionally those wouldn't take a lot of force, a lot of weight, but you can use a lot of these things to make molds and stuff like that for carbon fiber. We, like, for a lot of our molds, we're doing our carbon fiber knee trays and seats and chest plates and stuff. We 3D print those, and then we vacuum thermal form around them, or we do, wet carbon layups around them. And so that's game changer right there. Back in the day, you used to have to like route it out of wood, or, make them almost by hand. Nowadays, we can scan things and put them into a model and make molds. So it's really helped make things faster.
What's the safety factor that you referenced in that description?
So a safety factor is, if you have a factor of safety of 1, that means your anticipated force and the strength of your material are equal. So if, say, a carbon fiber tube would fail at 500 pounds, and you expect to see 500 pounds during the use of that product, that'd be a factor of safety of 1. It's much more common to have a factor of safety of 3, 4, 5, and even greater. The tricky part with like a bike is you do have to account for impact and things like that. So a user just riding down the road isn't going to put a tremendous amount of force into the members of the bike. But what if you hit a rock, you came around a corner fast, and all of a sudden there was a baby head there and you just hit that rock? That's a much larger impact. So we model these forces into our system, but the common term for modeling is, garbage in, garbage out. Your model's only as good as your understanding of the system, and the system is very complicated. So the way we accompany this is we model it, but then we take physically the lugs, the prototypes, and we put them into a testing device that can put 20,000 pounds of force into it. So we take and test all of our lugs to failure, so that we can back it out and proof it to the model. Because anytime you have humans, we have an individual. Justin's riding this bike and he's going to ride it fast. So we want to make sure it's safe for him. We want to make it as light as possible, but there is a balance, right? We want it to be light and safe. So we do a lot of testing on the bike, and we're going to have a full prototype in about a month, and then Justin will come back out here, ride it, give a lot of feedback to the students. It can feel a little brutal at times, right? When you spent months designing something and somebody's like, you need to move this. This is uncomfortable. I got a pinch point here, but that's the real stuff. Like, engineers need to hear that. We spend too much time in our CAD models and doing calculations. That's our safe zone, right? You talk to the client and they start giving you real feedback. And Justin's in product development, so he's really good at like giving pinpoint feedback back to the students. And so it's fun to have that dynamic there.
That's just a good insight into how the lived experience and collaborating with the end user is essential, really, for anything, not just engineering.
Yeah, absolutely. I mean, you don't want to be in an echo chamber and be like, oh yeah, good idea. Yep, good idea. Great. And then move on. You need somebody else to chime in.
What were the biggest barriers to that first prototype? Do you remember like specific challenges or any kind of memorable moments when you guys had like aha moments?
Yeah, absolutely. The aha moment was 3D Systems joining. We tried to make our very first prototype out of all machined aluminum lugs, and the machine time, the complexity of trying to machine things that just those kind of shapes was incredibly challenging, and we never got out of CAD space, really. We made a few prototypes, but we never got out of CAD space. So then we went back to the drawing board, and when we did a little more research and then ended up talking with 3D Systems, that was a game changer, because traditional subtractive manufacturing, which is what machining would be, is very limited because you start with a large block and you're removing material to get to something smaller. Additive is actually the opposite. The less you have, the less it costs because it's laser sintering that happens. You have lasers that will hit the titanium, which is a powder in a vacuum chamber. You only pay for the amount of material that you melt together. So it's actually the opposite. So as we continue to make these things lighter and more, these lugs lighter and airier, the actual cost goes down rather than up. From a machining standpoint, the more you remove, the more complex and expensive it gets. So that was a huge aha moment. Putting that first bike together, even though that very first prototype, I was really proud of the students. We had some students that just put everything they had into it. We ignored some ergonomics. We knew that we couldn't solve every problem in the very first generation of the build. So we really just focused on strength, handling, and overall, like, how did the bike perform when you were in it? And so that, we had an expo, our design expo, where we showcase a lot of our work. And we finished the bike like 2 days before the expo, and we showcased it to our community, and the Adaptive Sports Center came down, and like we had Chris Reed here talking about it. And it was just such a big pride moment for myself and the students, where it's just like, yeah, right, this isn't the final bike, but this is absolutely a bike that's worth talking about. And it's a bike that's worth doing iterations to continue to make better. I mean, we're in it for the long haul. Like I said earlier, I don't think there's any end in sight in changes for this. So that very first time, like, it was, you looked at it and you're like, wait a minute, that's a bike. And you get on it and you ride it and you're like, that handles really well. Like, all the things that you tried to calculate in the model, like, actually were happening. And so you're just like, oh, great. And so that was a huge moment for us. And now we're back to the drawing board and just trying to make it better.
With no end in sight, what motivates you, or what makes you passionate about these projects? What aspect is most rewarding to you?
For me, it's going to be donating bikes. So we've acquired funding. We're going to have 3 to 4 students working for the entire summer, improving and then manufacturing these bikes. And then through the Adaptive Sports Center, we're going to donate these bikes to families that come out to Colorado. So one of the really cool things that the Adaptive Sports Center in Colorado does is they bring a lot of individuals out here, and they show them everything from, this is how you'd prepare a meal. Like, these are many, oftentimes they're the newly injured individuals, and it's like, hey, things might not be the same, but that doesn't mean it isn't awesome. Why don't we show you all these avenues? And so they have fully accessible kitchens. They bring in cooks to talk about, hey, like, everything from mental health to physical health. These are all avenues, and they have a big social aspect of it. And so they pair people up to start making friends and, sharing stories. And so something that really excites me is that a lot of these people come out here and they get exposure to something like, hey, come ride these awesome gravel roads and trails, go have this experience. And then they may go home, and then they're like, wow, mom, dad, or, husband or wife, like, I want to buy one of these. And then the sticker shock hits of seeing what these would cost. And so our goal is to try to manufacture somewhere between 5 and 10 of these bikes and donate them this summer. And I know that's not a lot. That's not going to make a huge difference. But for those individual families, I think it will make a difference. And that's ideally just the beginning. I think there is an opportunity to collaborate with other groups and organizations, and to utilize the university platform, which is, we have students that are eager to learn manufacturing techniques, right? As they're building knee trays and chest plates, they're learning about how to do composite layups, right? They could be going into the automotive industry or aerospace, where they're going to be doing this professionally in other settings. And so to be able to have that as an undergrad in your portfolio, that, yeah, these are things I've already done, I think that can be really special. So the thing that motivates me the most is, I love building. I love seeing the product in the end, but seeing the product finished in the end and somebody using it, that to me, I feel most fulfilled, and I feel like I'm doing my part, being a professor, being in this this opportunity that I have, I think that's the one of the things that excites me the most.
Yeah, I mean, 5 to 10 bikes is not something to shake your head at. That certainly is going to impact a lot of people, especially if you extrapolate it over the course of a 5 or 10 year career, however long the project's sustained for. But as you were talking about that, I was wondering if you could share the work that you were doing with other engineering departments that could do very similar things for organizations around the
Yeah,
country.
yeah, we actually just had CU Boulder's bio medical group out here, and we are going to be launching a biomedical degree, and so I think that brings out a lot of opportunity to focus on biomechanics, potentially prosthetics and things like that. As far as collaborating with other universities. And just other organizations in general, I think we're really in our infancy. I think as we continue to get this message out, we're going to continue to talk to more groups and we're going to find more collaborations. I think working with some other bike companies would be really exciting and saying to them, like, hey, you're a for-profit. I get that. You're pushing this envelope. What areas could we help in? Like, do you have a bike you would love us to maybe have students redesign, or a product, or is there a process, right? Some of the things we do are about, it's called lean manufacturing. So how do you make manufacturing ultra efficient? Small changes throughout the design and manufacturing process, all these small changes add up to big gains as far as better use of material, better use of time, quicker turnaround. And so that's actually a class that our mechanical engineers take. And so we could even apply some of that lean ideology to other companies and say, let's do a case study where we completely analyze your manufacturing process. A lot of the bike manufacturers out there, especially in the adaptive space, they're just folks that were like, hey, there wasn't a product out there. So I started welding and I started making these bikes, and I'm good at it. And so maybe we could learn from each other, where they show us some things and then maybe we help with some of their processes. So as far as collaboration, I think we're at our infancy, and there's a lot of groups in Colorado that are in close proximity to us, especially with the Front Range only being 4 hours away, that I think we're going to, over the next couple of years, start forming some really good relationships. We've already talked with like Craig Hospital, for example. They have an amazing program. And so I think the opportunities are pretty vast. I think it's on us to slowly grow into this space and see how we can continue to form these bridges and collaborate a little bit more.
What aspects of these designs are patent protected?
I had a conversation with a lawyer about this, and I ended up at the idea of like, they're not, and they shouldn't be.
Mhm.
If we come up with something that's really, really unique and cool, and it just gets out there to this market, I think that's a win. I've had people ask me like, "Are you going to start a company with this? Or what's your goal?" And it's like, no, my goal is to just keep doing what I'm doing. Like, I've started a company in the past. I've worked and done those things, and I love teaching. Like, I just want to continue to do exactly what I'm doing. And so patents are an interesting thing. Like, in some ways they protect you, in some ways they don't. And our mission isn't in any way to try to protect or hold close to the vest any of our designs. Our idea is actually the exact opposite. And if somebody else is like, that's pretty cool, I want to start a company, and they do, and they get more of these bikes out there, I see that as a win, not a loss, for example.
Yeah, almost flipping that though, I would wonder if someone took your design, patented it themselves, and then didn't want you to create it, like they wanted to
Mm,
monopolize it. It's almost like you file a patent to protect someone else from
yeah,
filing a patent and then discontinuing your project. So it's not something I have any knowledge on, but that was just kind of the two
yeah,
sides of the coin I was thinking of as you were
yeah.
talking through it.
Yeah, I certainly think that that is a potentially valid point. But so far, my experience in this market is that it's a pretty supportive market. And I just think based off of the size of the like market share, you're not going to have a group come in and say to themselves like, "Oh, we're going to carve ourselves out a corner here. This isn't as big as e-commerce or anything like that." I
Yeah.
think it's a pretty tight-knit community. And so far, what I've experienced in it is that people just want to continue to help people. It's not quite the same competitive nature that you see in some other for-profit fields.
Yeah. What's the hierarchy of like function, aesthetics, affordability? What
Hmm.
would you rank? What would you rank as like the most important aspect of the design process?
So again, that engineering answer of it
Depends.
depends. On the performance bike, it's all function. You know, strength, weight. We want to get this as light as possible while still adhering to our factors of safety. Um, our goal has been to hit 13% grade on a climb while still maintaining traction. We've been able to get up around 12% with our prototypes, and I think our next prototype should be able to get up to 13. So those are the metrics we use for our performance bike. For our other bike, which is a recumbent bike that we're designing right now, the script is flipped a little bit. I think long term, it's going to be cost and weight. I don't see it being necessarily the highest performing, performance gravel bike out there. But if we can make it light, accessible, and a good price point, then I see that as a win. So that script is flipped a little bit compared to the performance bike, where students are really kind of pursuing like, can we shave 50 grams off here? What about 20 grams here? Every single aspect of it is just about performance. And then, if something looks cool, that's never a bad thing. But from a decision matrix standpoint, that would be pretty low on the totem pole.
What advice would you give to students that might hear something like this and think that they would like to get into engineering for adaptive equipment?
Well, I guess the first one would be feel free to reach out to me. We have an amazing program here. Students spend 4 years or 5 years, depending on their how they're approaching their engineering degree, in the Gunnison Valley, which is an absolutely gorgeous area. And you graduate with an ABET accredited CU degree, a top 10 mechanical engineering degree at an amazing facility. So if you're looking for a small class size, really hands-on experience, then please reach out to me. If you're maybe in another space and you're looking to get into this, my answer normally is just start asking questions. Just start talking to people, asking questions and following the next lead. We typically have more resources around us than we even realize. When I've chased down ideas before, I'm always amazed at, like, in my backyard, how many amazing resources are there, people that have experience in these areas. So if you're a student somewhere else, just start asking questions and then seeing where you can get into it. I think mechanical engineering is a phenomenal degree because of how broad it is. Yeah, as a mechanical engineer, you can go into biomedical, you can go into energy, you can go into automotive, aerospace. Like, it really is a gateway to almost any career path. So if you're looking for something that gives you a broad range, and this is in one of the areas you're interested in, mechanical engineering is a really good source. But yeah, that would be my advice.
If you reflect back on your career prior to teaching, can you identify any ways that the work you did could have benefited more individuals with disabilities? And I don't have the full picture of all the different directions your company went in, but like,
Yeah.
yeah, I guess yeah, I think maybe you have an idea as to
Yeah, I
what
mean,
I'm
I'm
getting
a
at there.
little embarrassed to say this, but like, I would say I did very little. I didn't think about it. It just
Yeah,
wasn't. Our company did a lot of fundraisers for local nonprofits that we had partnered with. We used our platform, which we were a large metal fabrication shop, so we had a really cool space, and we did a lot of these festivals where we'd bring in music and local breweries, and we'd raise money for local organizations. But the adaptive market just wasn't on my radar at all. It really wasn't until I got to Crested Butte in the Gunnison Valley and I started talking to the Adaptive Sports Center that it was like this kind of like slap across the face of just like,
Eh.
whoa, there's like this whole area that you've never really thought of from a manufacturing standpoint or a product standpoint. And I just got so fascinated by it because I saw so much opportunity. Like I saw areas, like I look at a car, for example, and I'm like, I'm not going to make that car better. there's a lot of years of experience that have gone into it. But I started looking at some of the like sports related adaptive gear, and then just some of the tools and things that were used for accommodation. And I was like, I think we can make this better, and I think we can make this better. And when we started talking to them, the Adaptive Sports Center in Crested Butte, the story was kind of the same. It was like, well, there isn't these big companies doing this. There's not these large organizations that are plowing a bunch of money into the pursuit of this. So that's when I got really excited of like, wait a minute, like seems like an opportunity, and I think students would be interested in this. And so far, I mean, maybe they're just telling me it because I'm their professor, but so far the feedback's been pretty good of like, wow, this was really enlightening. This was really challenging, and I'm glad I had the experience.
Yeah, I certainly wouldn't say it's something to be embarrassed about. You're running a company, and first and foremost, you're in your own lane. You're trying to create a profitable business.
Yeah.
The same thing, like I had no exposure to disability until I walked into a gym for Special Olympics. Never would have been on my radar probably if I had just kept going in the trajectory that I was going in. So I think everyone kind of has some experience or introduction to it where at some point they're like, what was I doing before? Why was this
Yeah.
never on my radar? But I think it's just, and maybe that's one of the reasons why there still exists a lot of environments that aren't inclusive and accessible because people just haven't been introduced to it yet.
Yeah, I think that's one of the cool things about this podcast and what you're doing. I mean, before this podcast, a couple months ago or whatever it was when we were kind of first having our conversation, you made a few comments, and I left that. You were talking about like, all right, if you're a blind athlete and you want to go up and use the treadmill, how do you find it? If you're in a wheelchair and you're trying to get between the two treadmills, how do you get in between them? Because they're not spaced out enough. And after that conversation, like I remember walking around, I was kind of looking at things and I was like, wow, how would you do this? And how would you do that? And so even some of those just like little seeds that are planted, I think there's a lot of value in just having these discussions, even if change isn't being proposed per se. You're just posing questions of like, have you thought of this? Because a lot of times the answer is no. And then once you do think about it, you start thinking to yourself, well, to make this better, it's not that hard. Like small changes, like kind of like when I was talking about lean ideology in manufacturing, how do you reduce waste in manufacturing? It's not sweeping changes. A lot of times it's small changes make huge rippling effects, in industry. So that's
Yeah.
exciting.
It's the same thing in the gym space where people have this misconception that accessibility are huge overhauls of the entire layout or the entire facility or these highly complex pieces of equipment. But sometimes it's just understanding the experience of an individual and figuring out, conversing with them, figuring out how their experience can just be marginally better. And ultimately, when I feel like when they know their voice is heard in the equation, then they are going to have a lot more leniency and understanding that you are taking their best interest into consideration when kind of designing these environments.
Yeah, I think that's a good way of putting it, like trying to think about somebody else's experience. If you kind of put yourself, the old, age-old adage, like you put yourself in somebody else's shoes. If you just think about their experience, like it's a good process to go through from time and time again to just kind of like see what it yields.
Absolutely. Well, this is a space that I have no experience in, the mechanical engineering world. So I've enjoyed learning from you, learning a little bit about the process. There were a ton of parallels, I feel like, in terms of mechanical engineering design process and accessible environments in the fitness space, in the classroom, and really any built environment. There were a lot of parallels between the two. So really appreciate you sharing that. Looking forward to seeing what you guys produce.
Absolutely.
If people are interested in following along with kind of that process, what would you recommend would be the best way to kind of stay in touch or stay up to date with
Um,
that?
yeah, so we have a social media for our university. So it's the partnership program in Gunnison, Colorado, and we post routinely on there. So we will continue to post how the process, how that is all going, and then potentially like after we get this bike built, and maybe after Justin does some races with it, I'd love to have another conversation with you and circle back and just kind of talk about how it went.
Yeah, absolutely. And if there's mechanical engineering students in my circle that might be kind of hear this conversation and think that I would love to bring that to their university, I'll definitely facilitate that connection with you and see if you can guide them in any
Yeah,
way.
absolutely. If they want to reach out to me, I'd be more than happy to
Awesome.
talk about this, this approach.
Yeah, we'll include the show. We'll include the social handles in the show notes, and as well as your contact information. But Greg,
Thank you.
I'm glad I sent a cold email to you a couple months ago. It's been a joy to talk to you multiple times over the last couple months, and looking forward to seeing what you accomplish.
Thank you, Brendan. I appreciate being on the show, and we will certainly be in contact as we continue down this path.
Thank you for listening to the AdaptX podcast. Our effort to amplify the ideas of our guests and create more inclusive and accessible industries is futile unless these episodes reach a larger audience. If you enjoyed our discussion today, please leave us a rating or a review on whichever platform you use. And if you would like to learn more about AdaptX, the course that we teach to health and fitness professionals and the projects that our organization is working on, you can subscribe to our newsletter through our website, www.adaptx.org. Until next Monday.